2 of section 1.1, solving linear equations. All right, so we're going to solve some more complicated equations. So we're going to add some more things to the equations. And we're going to look at order of operations and solve equations in that way. So let's look at this example here. This is number 8 on your notes, in your notes. Solve the following equation. What are the possible order of operations? Now, you might say, well, I got to follow the PEMDAS thing. And it's like, yeah, that works pretty well as a heuristic, as a way to approach problems with a kind of a recipe of steps or an order of steps. I want you to think, though, that there are other ways that you could approach this. There's just problems with them, right? There's reasons that we don't do it that way. So in PEMDAS, the first one is parentheses. And so it's like, clear out the parentheses first. Use the distributive property first is what that means. And so, well, why wouldn't you want to divide first? Because you could, and what would happen if you did? Well, in fact, let's look at this. How can I do this without messing up the notes too bad? I mean, for instance, right here, we could divide by 2, right? We could divide both sides by 2. Now, if we did that, though, we'd have to divide this expression by 2, this expression, which would be fine, because I'd get rid of the 2, and then also the other side by 2. So what you'd have is this weird 5/2 thing over here. You could deal with it, but then you've got a fraction now that you're going to have to deal with at some point later on in the problem. We could do the same thing. We could divide by 5. We'd have the same issue there. We'd have to divide this part by 5 as well. We could subtract, right? So we could subtract this 2 times 1 minus x over to the other side. That, again, doesn't help us very much, though. So the reason that we start with the parentheses is because the other things don't move us forward. They don't move us towards the solution in any meaningful way, especially the subtraction. That just kind of moves things around. So what we're going to do then is we're just going to distribute, and then we will have a series of terms that we can combine, and then we can ultimately do addition, subtraction, multiplication, division. Okay, so let's distribute the 5 here. So if I distribute that, that means it's going to be 5 times x and 5 times 3. So that's 5x plus 15. I'm going to distribute the 2. So I'll have plus 2 and minus 2x, and that'll give me 14. Combining like terms, remember like terms are numbers, integers, or, well, really any real numbers that can be combined. So 15 plus 2 is 17. Or terms that have the same variable with the same power. Okay, so we have 5x minus 2x. That'll be 3x. So I'll have 3x plus 17 over here is equal to 14. All right, and then I'm going to subtract 17 from both sides, because whatever I do to one side, I have to do to the other. That's kind of how this works. So I get 3x equals negative 3. Then when I divide both sides by 3, over here I get 1. So that simplifies to 1 over 1, and I get x equals negative 1. Or so you can actually see it, x equals negative 1. All right, let's move on to the next example then. Again, like any example, really, you should try it first, see how you do, and then play the video and see if you got it right. So let's go over to this example here. I want to distribute again first, although I don't have to, right? I could divide both sides by 3. In fact, let's do that. So in this case, it's going to work when I divide both sides by 3. On the left, I get 1 over 1. This is just 1. So I get 4x minus 2 on the left. And there's no reason to put that in parentheses because the 3 over 3 is just going to be 1 times 4x minus 2. 1 times anything is itself. So I have 4x minus 2 equals 2. I'm going to add 2 to both sides. So I get 4x equals 4. Quick note, negative 2 plus 2 is 0. That gives me the additive identity from the previous video. Right, so that's why that works. Anyway, I have 4x equals 4. And I'll divide both sides by 4. I get x equals a positive 1. Okay. Now, these properties of algebra that I sort of brushed over in the previous video, but that are here in your notes right there for reference, those properties of algebra don't need to just apply to a problem where you're trying to find one solution. So you can take these tools and you can use them in situations where there's not just one number that you're trying to find. So if, for instance, we have this formula here. It's the formula for the area of a triangle. It's A equals 1/2 times the base times the height. So if you have the base and the height, you plug those into the formula and it will output the area. Fantastic. Formulas are great. All right. And in this problem, what we want to do is, instead of a formula that inputs base and height and outputs the area, we want to input area and the base and get the height out. In other words, we want to solve this for h. Can we get h by itself? So we have two problems here. We have this 1/2, and the question is, how do I back up 1 second. I'm trying to isolate h. I want to get h by itself, right? So the question is, how do I get this 1/2 off of the right-hand side and over to the left-hand side? Well, if I have 1 over 2, if I multiply that by 2 over 1, and I have to do it to the other side as well, 2 over 1, then this will simplify to 1 over 1 and 1 over 1. So this will all just be 1, and what I'll get is 2a is equal to base times height. All right, now what I'm trying to do is get h by itself. If over here we had something like 7 times h, and we wanted to get h by itself, we would undo that multiplication by doing the inverse, which is division. So we would divide both sides by 7. Nothing changes with a letter, okay? So we can divide both sides by b. This simplifies to 1 over 1. And so I get h is equal to 2a over b. All right, and that answer is fine. There's no, again, this is a new formula, and I don't know why I capitalized b. I'm sorry about that. This is just a new formula where if you know the area of a triangle and you know the base, you can figure out the height. Okay, so there's no answer to find there. We just built a new formula, or modified a previous formula to make a new one. Okay. All right. Next one. Let's do something that's a little bit different, or maybe add some stuff to it. So same kind of idea. We want to solve this formula for the area of a trapezoid, which is given here. Sort of hard to see in the video, but you've got it in your notes. B sub 1 on top, B sub 2, and the height of the trapezoid. If I know those three things, then I can figure out what the area is. But can I solve this for B sub 2? In other words, can I set up a formula where if I know the base, and I know the height, and I know the area, I can get the other base? And so I always rewrite these. So if it's in your book or if it's on a worksheet or something, and it's not written in a convenient spot, then just rewrite it. All right. And so then let's take and work our way to isolating B sub 2. So again, I have this problem with the 1/2. I'm going to multiply both sides by 2 over 1, or that's just multiplying by 2. Okay, so I have 2a is equal to h times b sub 1 plus b sub 2. I'm going to divide both sides by h. Again, I have a multiplication issue, so I'm going to divide both sides by h. And that's 1 over 1 on the right. So I get 2a over h is equal to b sub 1 plus b sub 2. And I can drop the parentheses because h over h is just 1, just like multiplying by 1. So now to get b sub 2 by itself, I just have to subtract this b sub 1 over. Minus b sub 1 minus b sub 1. Here's my final answer then. B sub 2 is equal to 2a over h minus b sub 1. Okay, so there's my formula for b sub 2. And again, you've got to sort of get comfortable with this idea that you're not solving to get a particular number. You're just rewriting the formula in a different order so that the formula that originally was for area is now for the second base, base sub 2. All right. Last problem. Let's go to number 12. Number 12 is a little bit of a brain teaser one, I think. A bit of a brain teasing problem. So again, you should give this a try. Pause the video and see how it goes. Hopefully you tried it. 6x minus 12 equals 18. What is the value of 6x plus 5? What a strange question, right? We typically say, here's an equation, solve it for x. Or here's what we just said is, here's a formula. Can you rewrite the formula in a way that you get something else by itself? So b sub 2 by itself, for example. All right. And now we have an equation, and we want to know what an expression is equal to. We want to know what is 6x plus 5. Okay. And the way we're going to think about this is we're going to really lean hard on this concept of equality. Okay, let me show you what I mean by that. So here's what we want to know. We want to know what 6x plus 5 is equal to. All right. I know this. I know that 6x minus 12 is 18. And I also notice that there's a 6x in each one of these expressions. Okay, so there's a 6x over here and over here. So I think to myself, if I knew what 6x was, I could figure out what 6x plus 5 was equal to. So in this equation, I'm going to add 12 to both sides. And I'm going to get 6x equals 30. All right, so now I know 6x is 30. And in place of 6x, I can put 30. And now, just to keep this as clear as possible, I'm not going to replace the 6x, but I'll show you what I'm going to do. I'm going to rewrite this as 6x plus 5 is equal to 30 plus 5, because I know that 6x and 30 are the same from over here. All right, so now I can simplify. I have 6x plus 5 is equal to 35. And then I just solved the problem. So the answer is 35. But again, what we did is we said, all right, this equation has meaning, and I can leverage that meaning to figure out what this piece of the equation is equal to. All right, so I sort of had a puzzle to begin with, and I took a piece and substituted it in over here. So I basically said 6x is 30. Let's plug it in over there and see what happens. When we do that, we get 30 plus 5, which is 35. All right, that's it for section 1.1.